Hello and welcome to the next part of this tutorial series on how to make your first DirectX DirectX 12 application from scratch in C++. Um, on at the last episode, we did some preparation in terms of being able to render in 3D. We created a so-called view projection matrix, and I went over how to define coordinate systems. Next, we will be uploading this information to the GPU so that we can actually use this in our vertex shader to translate any position that we receive as input into 2D coordinate space. So that's the plan for this episode. We also want to bind that structure to our pipeline. In terms of constant buffers, they are buffers that are readily accessible for the GPU pipeline. You can upload constant buffers into the upload heap if you plan to write to them often, or you can bind them or rather upload them to the default heap if you don't plan on changing them a lot. This will probably on several platforms be an optimization, but since we want to be able to control our camera each frame, we will be creating this constant buffer on our upload heap so that our CPU can write to it every frame, or even whenever it wants. But we preferably would like to only write to it once per frame. So we need a utility function because a constant buffer has a certain memory alignment. A constant buffer must always be aligned to 255 bytes, meaning that it needs to be multiples of 255 bytes, no matter how much data you store in it. We plan on storing a matrix, which is a 4x4 matrix, which means that it has 16 floating point numbers, 16 floating point numbers with 32 bits, meaning 4 bytes each, will be approximately 64 bytes, if I'm not mistaken. So it's nowhere near the upper limit of the constant buffer, but we just have to live with that. The GPU architectures differ in terms of how efficient they are if the constant buffers aren't aligned to 255. So as a good practice on a broad of different platforms, it's wise to simply align stuff and um, experience a stable yeah, uh, that everything is as performant as possible between across different platforms. So we need a little utility function here that we will create in a folder called utilities. We will create a CPP and header file for that. I'll use the class creation method, but I will actually delete the class, and then I'll define a namespace here, and inside that namespace I'll also define something called utils, and this will simply return an uint which it will be a method called calculate calculate constant buffer alignment, and it will take in a const uint. Let's just do the same typing here. Allocation, and we will define it in our CPP file here. And we will simply return our allocation plus 255 bytes, ended with a bit shifted 255. So this will wrap our allocation into multiples of 255 bytes. It will always be 255 bytes at the minimum. So that's an utility function that we will use to define our buffer. In our rendering API here, we will create a D12 resource, ConstanBuffer for our so-called pass data. We will call it pass data because it will be something that is needed for every rendering pass, potentially, since it's information about our camera, which is needed in so many different kinds of shaders. So we expected to upload it every frame, and we expected to contain information about vital components or data needed by our shaders. We also need to define its contents. So we will have a data type that we will define inside our header file, and we will call this pass data, and we will use our DirectX XM matrix type here, and we will simply call it view projection matrix. Sometimes, oops, that's my other project identity. We can actually initialize it as an identity matrix, meaning qualifier. Huh. Let me look up this. I can't apparently. Let's see. Oh, I can. So yeah, we can initialize it as an identity matrix. If you don't know what that is, let me show you. An identity matrix is simply something that is defined like this, where the diagonal is 1 and everything else is 0. So in a 4x4 matrix, you can probably imagine how that looks. So we initialize that as that. We want our constant buffer to contain our pass data. So we created the data structure / resource here on the render API, but we want to initialize it, and we will give it our device. We will give it this size of the buffer, but remember, it needs to be aligned to 255 bytes. So we will do an include up here, where we include our utilities. utilities here. Excuse me. And we will ask our helper function here to calculate a align size of our pass data struct. So no matter how large we create how much we change that struct, we will get an align size. Then we want to create a specific heap, and we know when we create it on the upload heap that we need to specify both the upload heap and generic read as our initial resource state. And we simply pass in that information. And now we have initialized our buffer. Then you might recall that we can do this, but I think the time is ripe for us creating a little bit of change to our resource here. We want it to store a private pointer here that is its memory location, and we want a function here that returns its memory location, get memory. Let's do that. Let's create a function for that. And we can do if our memory is not set, we map the memory, and let's do a get here. And then on release, if we have a memory defined here, then we simply unmap it. So we simply call unmap. There we go. So now we can actually delete this, delete this, delete this. And then we can take our dynamic index buffer here, and we can get our CPU memory. And it will always map it if it's not mapped. And we can do the same thing here. But let's make sure everything compiles. Okay, we have a problem. Oh, wait a minute, we return a null pointer, of course. Well, there we go. Of course, we need to reset this afterwards, otherwise we can't unmap it. So now we should be fine. Oh well, let's see. We of course need to make sure that the interface is valid. Yeah, there we go. Okay. So now we can simply make sure that every time we want to memcopy something to our dynamic buffers on the upload heap, we simply ask for the CPU memory, and it will make sure that everything is mapped. And when we deallocate the object, it will of course make sure that that it gets unmapped. Okay, we would like our frame to start with an update of our actual pass data, since it's required for the current iteration of the pipeline. So let's ask for our memory location here. Then let's take our view projection matrix, and then let's write our past data. Okay. Now we have uploaded the past data to our GPU. Let's just test that everything turned out as it's supposed to in terms of the actual data ending up on, oh, we haven't updated the shaders, I think. It doesn't matter right now. We will do that later. Oh, wait a minute. We need to build in release mode. That's why. Because Inside runs on the release mode. There we go. Let's try doing it again. All right, that looks more reasonable. Let's try grabbing the information, and we have our buffer number 2. We haven't named it. We could do that, but yeah. And let's see if we define that this is supposed to be a float 4 times 4. We see that we have the first instance, which contains our view projection matrix. So everything got uploaded correctly. Okay. So now we have created our constant buffer, but we haven't bound it to our pipeline. On the CPU side, you want to bind it by simply linking it to the root signature. If you remember, our root signature here has a constant buffer view in its first parameter, and which is in the shader register 0 and the register space 0. It's available for the vertex buffer. So let me show you how to bind something like that. We need to bind it before we draw, because we will use it for draw calls. So it needs to be available. We will set a graphics root constant buffer view. That basically means that one of the root arguments will be set to a pointer to this specific constant buffer. Remember that it's index 0 since it's our first parameter, and then we need to specify the buffer location. And let's see if we ask for the pointer for the interface of the resource, we can ask for a GPU virtual address and simply pass that along. So this binds through the command list the constant buffer to the pipeline, and this should be fine. We have no errors here, even though it's happening every frame. So that means that the CPU side of things are actually done. We need to update our shader programs to access our buffer though. And I'll show you how to write the shader program for that. So since it's only available in our vertex shader, we will only define it here. We will create a constant buffer of a certain type. We need to define the type first. Let's call it past data. And let's store a 4x4 float view projection. And let's interpret the constant buffer as our past data here. And then we need to give it a name. Let's call it global past data. And let's tell it which register it resides in. So it's B for constant buffers, and it's B0 since our root signature specified that it's in shader register 0. If we had register spaces, we would need to specify that. That could be something like, let me find the vertex shader here, something like T0 or something. Or I think S0. Yeah, I can, maybe so. Yeah, something like this. Yeah, space 0. But we do not use the spaces, so therefore we... Hello, man. Welcome. So now this means that our GPU actually has access to our constant buffer since we have bound it through the root signature, we have bound it through the command list, and we have uploaded the data to the GPU, and therefore we can access it. Right now we won't do anything with it. We just needed to see that everything compiles. And that means we need to do the actual rendering and drawing in the next video. Since I think we got done with our outline for this video, let's see, we want to upload the camera viewpoint matrix and that translates. We want to create a constant buffer and bind that to the pipeline. We have bound it through the CPU side with command list registrations, and we have bound it on the GPU side through the shader program. Also, the root signature helped us define where to bind the actual constant buffer to the whole pipeline. And that's it. Since we have planned that our third video will be actually rendering a 3D box. We will also go into depth buffering in the next episode. As you will see, we will run into depth problems if we do not. All right, that's it for this video here. Are there any questions related to this video here or in general? Doesn't seem like it. All right, I'll end the recording and I'll see you in the next one where we will draw a 3D box draw screen. All right, thanks for watching. Feel free to comment, like, and subscribe. Follow on Twitch or even support the channel. See you in the next one.